GameSci.com. GameSci.com. What's up? I am Professor Chris Ferguson. Welcome to the video on JavaScript and Forms, where we transfer data from the browser to the server. HTML form elements are key to transferring data from the browser computer to the server computer. JavaScript plays an important role in verifying the data, perhaps changing the data, and even inserting new data during the transfer. It can be done directly by accessing the DOM or by using a third-party library like jQuery to automate form validation and notify users of problems before the transfer to the server takes place. Data goes from the browser or client computer over to the server computer, and it's JavaScript's job to make sure it's good data. An HTML form allows the user to enter data and send it to the server computer. This one contains input text boxes for the name and the age. Before the data is sent, a JavaScript program running on the browser side can verify there is data in the name box, can guarantee there is a number in the age box, etc. Users can and do make lots of mistakes. JavaScript can help correct them before time and money is wasted sending the bad data to the server. If there's nothing in these boxes, there's no sense trying to send it over to the server. Once the submit is pressed, the data is sent over the internet to the server computer. CGI stands for Common Gateway Interface, which packages the data so a PHP, Python, or other program can easily process it. This is a PHP example, but any computer language on the server side can process the data because of the common format. The reason JavaScript is so important is the more it verifies the data is good, the less time the server wastes trying to process an order with a blank name field or a credit card number of 12345. Make the user fix this bad credit card number before you transfer the data over to the server. Let's look at a code example and start with HTML name versus ID. What's the difference? The ID and name attributes are very similar, except when it comes to a form. To properly send data to a CGI program on the server, you must use the name equals attribute to identify the form element. Using name equal also builds an object in the DOM so you can access the element. We spent a lot of time using the ID equals attribute, and for forms especially, you have to get used to using name. Form name equals my form, action equals http://my URL. The form tag's name equal attribute will be used to create an object in the DOM that allows JavaScript access to all the elements in the form. The action equals attribute identifies the URL or address of the CGI, Common Gateway Interface program, that will process the data on the server side. My URL is a fictional address. Don't try to use that. I just wanted a short address so it would fit here on the slide. Input type equals text, name equals my text, value equals start. The input tag's name equal attribute will be used to create an object in the DOM that allows JavaScript access to this element in the form. It will also be used to identify the data on the server side. The type equal makes this a text box. The optional value equal attribute allows an initial value in the text box. If you look very carefully, this is the my text field on the screen, and inside the field we'd like the value start. Input type equals text, ID equals my age, name equals my age, value equals 0. The input tag can be used with ID equal, but the ID is only good with JavaScript on the browser side. It is not transferred to the CGI program on the server when the form is submitted. Thus, the name equal attribute is needed if you hope to see the data on the server side. Use of the ID equals is optional, but the name equals is required. The important one is the name equals. This is the my age field on the form. It has an initial value of 0, and if you look closely, we put a 0 in that text box. Input type equals submit. The type equals submit makes this form element a button that when pressed will transfer the data in the form to the CGI program on the server. The data on the server side will be identified by the name equals attribute of the elements transmitted. Note the arrow pointing to the HTTP my URL. This URL is where the data is sent. When this button is pressed, I want to send the data to this web address. Bang! The submit button is pressed, the HTTP my URL program on the server is run, and the input data is transmitted to the server. Note how the server identifies the data using the name equal attributes from each element. You must use name equal so the server can see the data. If you look very carefully, my text is a field in the form. My text is how we access what was typed into that form. Start. My age is the name attribute on the form. That's this field right here. That's how the server program accesses what was stored in there. The start was transferred in under my text. The 0 was transferred under my age. Let's switch over to the JavaScript and what JavaScript can do to this data. The data transferred is kind of useless. Start and 0 for the age means the user didn't even type anything into those boxes. They just left the default values before they hit submit. This is where JavaScript is important. Before, during, and after the form is submitted, JavaScript can test, change, or block any data being sent. The code below is just a small example. Much more is possible to do. Document.myform.mytext.value equals first change, and look what it does to the form on the browser window. This is the DOM. An object is created for each named form. Inside the object is an object for each named input, which happens to have a value attribute property we can change to whatever we want. Usually the value is examined first, then we change it if it's not satisfactory. Here we're directly changing it. If you follow the arrow, I'm saying I want to put first change in the value field of the myText object. Well, this is the myText object, and first change replaces the initial value of start. Document.getElementById myAge.value equals 19, and you can see a 19 shows up in the form element on the browser window. This is the DOM. Everything you've learned about using ID to access and or change elements on a web page still works if you add an ID equals attribute to the element. But ID is not transferred to the server, so you would still need the name equals attribute to send the data. If you prefer this technique, feel free to use it. If you like putting an ID on a tag and changing the element using the ID, it's perfectly okay, but remember you still have to use the name equals attribute in order for it to show up on the server side under that name. Bang! The submit button is pressed again. The HTTP my URL program on the server is run and the input data is transmitted. Note how the server is sent the data that JavaScript modified. The usual pattern is when the data is bad, fix it, then send it, or ask the user to fix it before you press the submit again. When the submit button is pressed, whatever's in this box is transferred to the server under the name myText. Whatever's in this box is transferred to the server under the name myAge. Notice how this wasn't what a user typed. This is what JavaScript wanted to put into those fields. That is perfectly legitimate for JavaScript to add its own data to a form before it's transmitted to the server. Note what's going on here. See the myForm here? That matches the name myForm there. See the myText here? That matches the name myText here. See the dot value here? That is the attribute value for this field. Learn the patterns, master the DOM. When you understand myForm and myText are objects created using the name equal attribute in the HTML, the value property in the JavaScript is the value attribute in the HTML. When you know the pattern, you can access or change just about any element or attribute on the form. ID equals myAge, name equals myAge. get element by ID, my age. Clearly we're talking about this attribute. It is 100% okay to use ID equals and get element by ID, especially if it makes your form code more consistent with how you change other elements on the web page. But remember to also add the name equal attribute so the data is properly transferred to the server. Again, learn the patterns. Notice the big difference here. We're using .value equals 19. Normally when we use a get element by ID, we're changing the inner HTML. But this is an object, and an object has variables or properties. Inner HTML is one property we can change. Turns out value or any attribute in a tag is another property of an object that we can change. We're changing the value property to 19. That means the 19 will show up inside the input box. Verify forms. Now let's transfer good data from the browser to the server. The most important role JavaScript plays in form processing is to verify the data entered into a form before the data is sent to the server. Amazon processes 66,000 valid orders per hour. The last thing they want is to have their servers trying to process orders missing required credit card data. Therefore, JavaScript is used to make sure that the user has entered reasonable data in the credit card fields before it's sent to the Amazon servers. Think of all the millions of orders Amazon processes. If half the time they are processing bad input, that's going to bog down the Amazon servers. So let's look what's happening on the browser side or the client side of the transaction. Here's an HTML form with a card number, a month, and a year. The month and the year are the expiration date of this card. All the data in the above HTML form is wrong. The card number is too short. There is no month 14 on the calendar. And the year 2019 has already passed, so it couldn't be a valid expiration date. It is important for JavaScript to stop the submit of the order, inform the user what is wrong, and ask them to fix this data before it's sent to the server for processing. That's the job of JavaScript. Every time this submit button is pressed, the data is sent to the server, and it arrives in the server. Every time the submit is pressed, the data is sent over the internet to the server computer, and it costs time and money to deal with that submit. If your server is processing 3 orders with bad card data, for each order with valid card data, it will slow the response time of your server. If it becomes too slow, then money must be spent to upgrade your servers. The idea is JavaScript will fix many of those bad submits and save time and money spent trying to process bad orders. When the data gets to the server side, it then has to contact the credit card company. Well, what's the use of sending a credit card company month equals 14 as expiration? It's just going to tell you it's wrong. So the sooner you can correct and fix it, the better. And the less time the server spends processing data, it shouldn't even be looking at. I shorten these examples, get them to fit on this slide. Keep in mind there may be some attributes on the tag here left off. Things like make the font color red. Please bear with me, it was hard to get all of this example onto one slide. Card number, input name equals card, span ID equals CM/span. Set up an input field for the user to type in a credit card number. To speed things up, assume it's the user that types into this field the number 123. The span is for JavaScript to use if it does not like the value stored in this field. Again, it's the user that typed in this bad credit card number into this field. Note also that this span is right next to the input field. Month, input tag name equals month, span ID equals MM. We're going to set up a month field on our form browser so the user can enter the month their card expires. Set up an input field for the user to type in the credit card expiration month. To speed things up, assume the user types into this field the number 7. The span is for JavaScript to use if it does not like the value stored in this field, and you'll notice the span is right next to that input box. Year. Tag input name equals year, span ID equals YM. Put this field on the browser window. Set up an input field for the user to type in the credit card expiration year. To speed things up, assume it's the user that types into this field the number 2099. The span is for the JavaScript to use if it does not like the value stored into this field. And again, notice how the span is right next to the input box. Again, I left off a lot of details there, the form tag at the beginning, the / form tag at the end. We looked at that on the previous slide. You should know enough about forms to do this now. Let's move over to what happens in the JavaScript when you submit this form. Boom! The user tries to submit the order form with this data. Before the data is sent, the JavaScript below will run to verify the data in the form. If the data is good, it should transmit to the server. But if the data is bad, the user should be informed and the submit should be blocked so the user can fix the bad data on the form before it's sent to the server. So a submit button, again, I left off that detail because I didn't have room for it, but a submit button would be pressed and it's going to try to submit this data, but the JavaScript should check it before it sends the data to the CGI program. If document.order.card.value.length is less than 16, check what's in this box. See if it's good. Before the data is sent to the server, the JavaScript runs to verify the data in the card field. The value is 1234, so the length of that value is 4. And this evaluates to if 4 is less than 16, which is a true statement. But a valid card number is 16 digits long. This data clearly fails this verify of the data in the card field. If this statement is true, it's going to enter the if statement and execute this code. Document.getElementById cm.innerHTML equals too short. The card number was invalid. Tell the user why it was invalid. Follow the arrow. Find the element with CM and display the message right next to the input box that the card number was too short. There are several more tests for invalid card numbers, but there's not enough room on this slide. You could have checked for the card number's too long. You could have checked for ABC and letters like that in the card number. I myself prefer to be as specific as possible. But you get the idea here. If you don't type in enough numbers, there's no sense sending it off to the server. If document.order.month.value is less than 1 or document.order.month.value is greater than 12. Before the data is sent to the server, verify the data in the month field. The value is 7. That is a valid credit card expiration month. The if 7 less than 1 or 7 greater than 12 is a false statement, so this code will not display a message. Notice this arrow here. We're going to skip past this line below because that's not a bad month. It's a good month. Leave it alone. There are several fields you're going to have to check, and some of them may be good and some of them may be bad. It's important to highlight the bad ones and leave the good ones alone. If document.order.year.value is less than 2022 or document.order.year.value is greater than 2033. I did this slide in 2022. Before the data is sent to the server, this JavaScript runs to verify the data in the year field. The value is 2099, so this evaluates to if 2099 is less than 2022 or 2099 is greater than 2033. And this clearly fails to verify the data in the year field. A credit card that expires 77 years from 2022 does not exist. Again, I did this slide in 2022. I generally don't like to use hard-coded. This should probably be a variable for the current year, and this should be current year plus 10. But I wanted to show you so you could see it with hard-coded values. Clearly, no one has a credit card that expires 77 years from today. So that has to be invalid, and it's not worth sending that data to the credit card company to ask if it's good. Document.getElementById ym.innerHTML equals bad year. The expiration year was invalid. Tell the user it was invalid. Follow the arrow, find the element with the ID equal ym, and change its inner HTML to bad year, and it'll show up right next to the input box for the year. The red text is on purpose. It draws the user's eyes to the field and tells them it needs to be fixed. Again, I had to shorten this example. I probably would have a style of red text in this span tag. And of course, this would be in a form called order for this code to work. But you get the idea, right? We need to tell the user something's wrong in your data before you send it to the server and allow them to fix that data. That's the important thing. The sooner you pop up these messages, the sooner they know to go back and fix it. Since some of the data in the credit card fields is obviously not valid, the order form should not be submitted to the server. Inform the user to fix the invalid fields and resubmit the order. To be clear, you cannot prevent every bad submit, but you can prevent obviously bad data. Again, we're not trying to block everything, right? As long as the year is reasonable, as long as the month is reasonable, we'll send it and then forward it to the credit card to see if it's actually good. But if they leave this field blank or put the year 2099 in this field, there's no sense bothering the credit card company to ask if that's valid. We know it's invalid. Why even send it off to the server? Make the user fix it, then resubmit and send reasonable data to the credit card company. Ooh, that wraps up this slide. Again, I kind of shortened a lot of this in order to get it to fit. Be sure to read the lecture for this lesson. I can go in a lot more detail because I have a lot more room. I can show you a lot more great form stuff. For instance, month and year typically are pull-down menus. So you know you're going to get an option from the pull-down menu. And I'll show you how to do pull-down menus in the lecture. So please read the lecture too. Thank you and have a good day. We'll see you on the next lesson.